All right, I too have a schedule to keep, so with that it's 12 p.m. exactly, and we're welcoming Andrea Martorana, who is here to talk about cross-apply. It's all yours.
Thank you, Dan, and welcome everybody, and thank you for having me on this call today. So let's start sharing something. And congratulations, Daniel, because the pronunciation of my family name was perfect.
I know just enough Italian to order ice cream and buy train tickets. That's all I do.
Okay, but you managed to do it very politely, so thank you very much, because it's not often happening. So yes, I'm from Italy, but actually I'm living in Denmark because I work for Pandora. And my role is BI front-end engineer. I'm doing mainly Power BI stuff in Pandora. We are embedding Power BI into SharePoint, so I'm following this portal that we have in the company, along with some other stuff, mainly around governance. And my core business has been BI along all my working life, so more than 25 years now, mainly focusing on Microsoft BI stack. And this is why I'm MVP for data platform. Speaker in many events. I told Daniel this year, unfortunately, I cannot come to SQL Saturday Gothenburg. I hope that all of you will join, and I strongly invite you to do it. But I've been in Gothenburg many times, in Finland or any other some other events worldwide. So the topic for today, it's the apply operator. I mean, it's nothing new, but I hope that there will be some interesting hints that you can get from the session. I have plenty of demos, so hopefully you will enjoy and you will get maybe some new way of thinking. This is my goal. And feel free, of course, to ask questions. Ask me anything any time. There's not a time for questions. Just when you have something, or you can type down in the chat or ask me. That's fine. We introduce then the apply operator. Apply, it's a table operator in t-sql. Tables operators are operators that usually act on tables provided as an input, and then you apply some logic, query, processing, and return, and the output is another table result. Common table operators in SQL Server are, for example, join, apply, pivot, and unpivot. Please note that apply, pivot, and unpivot, they are not standard SQL operators. So they exist only in SQL Server. In t-sql, I have a slide at the end of the session because there is something pretty similar to apply in SQL, in standard SQL. We will discuss it as the last topic. So we are focusing on something that is the t-sql language that works only on SQL Server. In the case of the apply, you usually call a function in the form of a table value function. We will discuss it in a few moments. I think the most difficult part is to understand exactly how the apply works. I tried to sketch out to create some pictures on it to get, because it's not so easy to understand. But let's discuss how to use it. It's an alternative to the joins and to subqueries, because you can face some limitations using these two operators. And it was introduced in SQL Server 2005. I think this is really the main concept. So you are joining a table and a function. I will show you many examples. I will show you some pictures, because this is for me the key concept to understand how it works and why sometimes you need to use it. Anyone with comments or experience is welcome to share and to talk about it. Because using apply, so you have a function, you have a table, you have a table, you have a function, then you can really simplify your expressions. The script that you write down, it's easier to read, and it's better, easier to debug when you have to do it, rather than writing a complex SQL standard code. Let's see how the apply works. So you have an operator, and you pass an input set. Usually you have a table. On the left side of the expression, you have a table. So I have a table, and I have a table with customers. Just 3 customers, customer ID and customer name, very simple table. So this is our input set. This is what we are passing to the operator as an input. What happens now? I want to see the last or the top 3 orders for each customer. This is what I want to see. For doing it, I already have a function, so there is a function prepared. I'm passing the input to the function using an apply operator. So apply gets the set of input rows and applies the function to the and passes the rows to the table valued function. It calls the function once for each row and returns a table. I understand is not probably is not easy to follow how it works, but if you take a look at the output, then you understand probably better the concept, because then as an input I am passing one table with 1 row for each customer. Then the output is as many rows as we have a correspondence in the function. So I'm browsing through sales or order tables, whatever, and what I'm getting is and then I have a top 3 in my function. You will see the example. So I have a top 3 in my function. So the output is not 1-to-1, but the output is as many rows as you can find out in using the function. So for the first customer, I have 2 rows. For the second customer, I have 1 row, and for the third customer, I have 3 rows, because this is the top, the max that I put as a upper cap, and I want to get 3 rows. But so it's kind of exploding the input. I have an input, and the input is 1 row for each different customer, and then it explodes the rows, giving me more as many rows as you find as a correspondence in when calling the function. I hope the concept is clear, and there are some other samples to explain it. When you think, okay, probably when you step into the apply operator, you can also think, okay, but why shall I use apply versus join? So what's the difference using an apply and using a join? So if you think about join, and now the standard join operator works. Of course, you have an input join, an inner join. Just a quick recap. Now, so you have two input sets, and only the output is only the matching combination because it's an inner. So every time there's a correlation, then you get an output. Then you have an outer join. Again, two input sets, full rows from one or both data sets. Depending on the type of join, you have a left join, a right join, and a full join. You also have the cross join, all possible combination of all values in your data sets. And when you think about apply get a left input set, a table, for instance, and evaluates for each row as an input using a correlation. And the output is the unified results of evaluation. So you have a row, call the function, and then so you have a customer A, and then you have as many rows as you find out in the correlation for this single customer. And it's replicated for each row. So you are really browsing row by row in your input set, and the output is as many rows as you find out depending on the function that you wrote and the correlation. There are two flavors, cross apply and outer apply. Cross apply, it's kind of inner join. If there is no match, then there is no output. Outer apply, it's can be assimilated to outer join, because if there is no match, then the input row it's provided with a null. So it's more or less the same concept that you have when you are using inner or left or right or outer join. Let's see how the cross apply works. I have again a left table, and this is my script, my query. So I have a sales customers, so I have a customers table, and I get I want to see the 3 top orders for each customer. So this is the syntax cross apply, and I'm calling a function. What happens? I have an input table, and I have a function. The function acts as the right table in my join. It's not a join, it's an apply, but you are matching the two objects, let's say. So you have a left table and you call a function. And depends on the orders, what you get from the order table, then you can have 2 rows from the first customer because it has only 2 orders. Second customer, it has 3 orders. Last customer, there is no order. So in such a case, the output is a table with as many rows as you can get from the function. So you have 2, the final output is 5 rows, and you have 2 rows from the first customer, 3 rows with the last 3 orders from the Epsilon, the second customer, and then no rows because this is a cross apply. So there are no rows because there is no matching. So there is no there are no rows for the third customer. No results. Same function, not function script, but using an outer apply this time. So we have the same concept, calling customers, passing the customer ID to the order table, and then you have again the same output, no results as well. But as you are using an outer apply, then you have an empty row for the last customer. So there is no output, there's no result, but you have an output because there is no orders in the order table for your third customer. So this is the main difference using a cross apply versus another apply. Again, it's the same kind of the same concept of inner versus outer join. Okay, so a very key concept is that in the apply operator, we are 99% of the times we are calling functions. We are calling user-defined functions in SQL Server. So just a quick reminder, what kind of functions we have in SQL Server? Scalar functions that return just a single value. Then we have inline table-valued functions that return the result of a SQL statement. Multi-statement table-valued functions. In this case, you have as an output a table variable. And you also have a CLR table value function, common language runtime functions that are written in .NET, and you can encapsulate, you can embed inside the SQL Server, creating an assembly. I have an example for it. So don't worry, if any question comes, we can watch it. Scalar functions you cannot use with apply because you need basically a select statement with some output. It can be either one single row or a table, but you need basically a table, not just one single value. And as a rule of thumb, you should avoid to call scalar functions because of the performance issues. It's a different topic. As long as it is possible, try always to write your functions in the form of inline table-valued functions. Functions that are pretty much assimilated as views. The query optimizer, once you write the function as a inline table valued function, the query optimizer thinks that the function is like a view, so you can benefit the most of performances, and the query optimizer can give you the most performing plan. Just a standard script for creating an inline table valued function. So you have to use this returns table as a return, and then you have your select statement here. This is coming from the official documentation. Okay, so that was pretty much all of the theory inside it. I don't know if there are already questions, because now we are ready to go to the demo part. Is there any question already, Daniel?
No questions that I could see.
Okay, fine. So let's go and move to the demo. So the first demo is that I want to, oh, sorry. How can I? Okay. So the first demo is that I want to calculate just simple sample for time differences. I want to calculate the age and the seniority in the company for every employee. And I can also, I can also calculate the average period of staying. But let's say I want to calculate age and seniority for every employee. How does it work? Okay, so some of the samples are based on Adventure Works database that all of us know. Some are based on custom database that I created for that. If it's the case of the Adventure Works, then you're able to replicate it basically. Okay, so I have
just
yes,
for the purpose of the recording, could you zoom in on the code just a little bit?
Yes, sorry.
Yeah,
Yes,
no problem.
Yes. That was my intention actually. Is it better now?
It's perfect. Thank you.
Thank you very much. Okay, so just the human resources employee from the venture works, so nothing fancy. And if I want to calculate for each one the age, I take just the date diff, then birth date, today minus birth date in months, and I divide by 12 and blah, blah, blah. Nothing fancy here. And actually, it's a bit into the output. Okay, so I have employee age and employee seniority for each one. But what if I want to make it into a function? I want to create a function, so there's no need every time to write this script. Just I create a function, and the function, then I can call the function, and I can get directly the output from the function. So I'm creating an inline tabled value function to calculate the time period in years and months. And this is the syntax for having what I called an inline table value function. It's a very important concept, so I'm stressing it because it is a view basically. So this is the best way for having good performances on your script and for having a good execution plan. This is the syntax return, and this is a standard t-sql syntax. Returns table as return, and then you have your select statement. This is a very simple select statement. What I'm passing is an input date as a parameter to the statement, and then it's doing exactly the same. So just a simple date diff in months, input date, today, blah, blah, blah. And this is for the years. And then you take the mode from the equation as a number of months. So there is a function. How the function works. Then we're calling out a function. This is how I have to do because this is a inline statement, inline table value function. So I have to call it using the syntax select from the function. I'm declaring an input date, just a date, and then I'm calling the function. Okay, so this is the output from the 1st of January 2000. It has been 22 years, and that's okay. So now let's call the function into our employee table. So what I'm doing now is that I'm calling the employee table, and let's do it. And I want to calculate the age and the seniority for every employee based on the data on the employee table. So this is the birth date for each of my employees. So what I'm doing now, it's this is the input, and this is the left side of the operator. So this is my table, and I'm passing basically the date of birth as a parameter to the function. So I'm calling a function, and I'm using a cross apply. It means that must be a one-to-one correspondence matching, and of course in this case I'm not doing any, I'm not doing any explosion of the function, because it's just passing one date and then getting an output. So this is how it works. I pass a parameter, and then the output is the age of the employee, and it works the same if I pass a higher date. So I'm calculating the seniority, and now comment this one and this one. Okay, so it's fine. It's okay. So I have a higher date and then seniority. It's the same concept. So for each one, 2 calls of the same function. So for every time you deal with some date calculation, my advice is that you might encapsulate your logic into a function, and then your code gets better and easier to read and debug, rather than having, because, okay, maybe this function is not so, or this calculation is not so complex, but it happens now that when you have to deal with dates, then you want to calculate, I don't know, end of months or whatever. So your select is going to be very, very long, probably. So encapsulate it into a function, and then it's absolutely easier to read. Okay, so that was the first example. And let's come to another topic, that is string split. Very, very, very classic problem in the old times. Actually, we forgot about it, and we see why. But it was a very common problem in the old times. So in the 2000 something up to 5 years ago, it was a very common issue. So how to deal with the string splitting and how to make it work. Yeah, there is a bunch of documentation online. So let's say, suppose you receive a string in this format. This is in Italy, we have regions and we have provinces. So this is the name of the region, and this is the name of the province. So for each region, you have more than one province. Just how it works in our boundaries. So yes, so I want to split because I want 2 rows for each. No, sorry, 1 row for each province. So in this case, I have this as an input, but I want to translate into a table with 1 row for each city that is in my column. Very, very, very common problem. And you can do it. You can solve it with a user-defined function. But so we forgot about it because in SQL Server 2016 was introduced the function string split that is doing the job for you. So actually, you don't need to build your own user-defined function anymore. But I think it's a very good example for understanding how it works, the apply operator. And again, actually, we used it a lot because of before the introduction of this string split. So I think it's a pretty good case actually for understanding the behavior of the string split.
String split is not perfect. It doesn't guarantee the order of the output.
Exactly,
that's one of the things I constantly run into.
Exactly, yeah. And actually, in my sample, you have an order sorting. So that's true. That's true. You have no sorting. So exactly. So then you have to do a CTE maybe, and then sorting out blah blah blah. Yes. So yes, that's true. That's true. Good point. Thank you, Daniel. Good catch. Okay, so I how to say, I didn't reinvent any wheel because the function I took from forum online. There are really plenty of documentation around it, so it was not me just being fancy stuff, but wrapping around what I needed. So let's see. The starting point is this table, and in this table, oh, wrong database. In this table, I have a list of regions, Italian regions, and I have, for each region, I have several cities, and they are split by a pipe operator. So my goal is taking this table as an input and then translating this table into horizontal table with as many rows as I have in each region. So by the way, there is no fixed structure. No, you see that for one region I have just one city. For another region I have I don't know, 6, 7, whatever. So the number, and this is another important point now for the operator. So there is no common pattern. There is no fixed structure. It's just that you browse and you get as many matches as you have into the table. Might be 1, might be 2, might be 9 or 1000, whatever. Okay, so what we did was creating, and this is the function for doing the splitting. Again, this is not coming from me. It's coming from the online documentation that I found out. Basically, it's using a recursive CTE for doing the trick. So you have in this inner part, you have a recursive CTE with some char index stuff, blah, blah, blah. And then you are combining everything into using a substring, and there is also a row number for the sorting. What is passed to the function is the output. So the output is input. Sorry, not the output. The input is this column. And the operator, the separator, so which delimiter you are using. It's either comma or semicolon or whatever. When it's possible, I prefer to use the pipe because then there is a limited risk of having a character in the string that messes up your query. So this is what we are doing then, just calling the table region list, cross apply the function, and passing as a parameter to the function the column. So it's a field, it's a column name, and the separator, what the delimiter is. And this is the output. So you have a table now with as many rows. Oh, no, I missed this one, but you have a table, and for each region, you have as many rows as cities there were in the input column. The number of rows might be different, and you can also have sorting. I think I'm sorting somewhere, but if I'm not, anyway, I have this row number that allows me to sort out, or if I want, or you can define your own sorting criteria. This is the custom function that I wrote. So this is my custom function. I told you we already have a built-in function. It's the same concept. As it is a function, you have to call it using cross-apply, using the apply operator. So the fact that it's a built-in function doesn't mean that you have to use a different syntax. You have to call a function using the apply operator. And then it works exactly the same way, apart that, as Daniel said, there is no sorting option here. But in this case, this is the same output. So it's exactly the same concept. You pass the input column, then you pass the delimiter, and this is the output that you get. But in any case, it's a function and it's an inline table valued function, so you need to call it using a cross apply. Okay. We can also do string splitting using common language runtime functions. This is not, this is a case where you can do it something in .NET and then applying it to your table. And I have a better example for it so that you can understand why sometimes you might want to use common language runtime functions. I have a couple of them. So the first one is, the first one, number 3. Okay, so how it works. Firstly, I need to, again, it's coming from online forums, so it was not me. But what you need to do is to create a .NET function that does something. So you have your solution, and you have your class or whatever, your script. And this is a C# script doing something. It does exactly the same stuff. So it takes the input and splits the input based on the delimiter that you pass. So the concept is the same. Once you have your script ready, you compile it, and it creates a DLL. So you have a DLL somewhere here. There is a DLL. And you have to this one, so you have a DLL, and you have to register the DLL into SQL Server. This is the tricky part, let's say. So you have to register your DLL into SQL Server. For doing it, you have to do a couple of preliminary operations, because your database must be declared as trustworthy. In this case, my database is already trustworthy. If it's not the case, you have to go here and say alter database, set trustworthy on. Trustworthy means that the database property, it's a database property for indicate whether the instance of a SQL Server it's trustable, and the content it's inside it is trustable, because then you are inserting something that is coming from external, so might be risky, because you have a script and you must be aware of what your script does. The other step is to configure, to enable this CLR reading into your database. So this is another step to run exec xp configure CLR enabled. Once your database is set, you can create the assembly. I already have it, so I cannot do it because I cannot create the same assembly twice. So, but what you need to do is to register an assembly. And this is important, the permission set. So this is the standard script, the standard syntax for creating an assembly. Just the name of the assembly, and then from the DLL name with permission set. There are different types of permission sets. It's either safe, means that there are some limitations. The script cannot read outside the database. There is external access, and I have an example for it, meaning that you can read something outside the database's perimeter, let's say. And there is also unsafe. And sometimes it happens that you have to register something coming from online sources, whatever, and you are forced to register as an unsafe. So SQL Server is basically saying, okay, it's your own responsibility. Don't bother me if you are doing, if you are screwing up something, because it's you that you are stating this is unsafe. Then I have registered my assemblies. So I have a couple of assemblies here. These are custom assemblies, these two. So I have a couple of assemblies. One for, one for doing this string split. The other one, it's the next topic. And I have different accesses here. I have different set. Come on, where are you? Okay. I have in one case, safe access, and in another case, I have external access. Okay, how does it work? I have my assembly registered. I can create a function, and the function gets two parameters, as usual, because you need the input column and then the delimiter. Returns table, blah, 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 as external name. And this is the syntax when you register a CLR function. So you have to call the namespace of your DLL. Let's see how it works. In this case, I'm passing a script string as an input directly into the function call. Goofy, Pluto, Donald Duck, blah, 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 and the delimiter is semicolon. It works exactly the same as the previous function. Takes the input and translates into rows, basically. I can do the same for the previous table that I showed you, the region list. It works the same, it's the same concept. List of regions and cities, and just convert into a list, one row for each town. Okay, then you might wonder, why are you doing the same stuff in this weird way? Because there are some cases where the CLR function might really help you, and this is the next demo that I have. Because in this case, I have a function that is doing something different. Let's have a look here. So this is another script, C#. Okay, so what this script is doing is that is getting a directory, a Windows directory path, and then it browses through the directories and it gives you the contents of the directory. So it's pretty nice because from SQL Server, you are reading your Windows file folders. So I don't know, maybe it's something that can scary someone, but yeah, it's pretty nice. So with this script, you can read directly your Windows folder structure from SQL Server. So let's see how it works. Again, I'm not going into this list of steps because it's the same concept. So you have an assembly, you have to register an assembly. In this case, I'm just pointing the light on the permission set because you need to define external access. You are going to read something from outside. Okay, then create the function. And let's see, I have a ctemp directory into my PC. Where are you? Windows. Ctemp. Okay, so I have a directory ctemp. This is my folder directory. And if I pass this directory to the script, the output is that I have the list of files into that directory with some other info, the file size and the last time the file was modified. So I'm reading these four files from a function call in a SQL Server, and of course, so it's reading external. So let's say that I have an input table, and in my input table, I have some folders path. These are some folders inside my own machine. I can do the cross apply. In this case, I'm using a outer apply because if there is nothing, so I just get an empty row. So I'm calling a function, I'm passing the path, the directory name, and this is the output. So for each directory, it's reading the list of objects that are into the directory. Items, maps, blah, 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 F, blah, blah, blah. So this is really going into this directory and reading the list of files from here. And of course, as I'm using a cross apply and an outer apply, in this case, it's browsing through all the input. So I have an input, and the input is a folder name, and then it's exploding, you know, because as long as there is a matching, then you get an output. So this is a real power. Now we are doing something fancy because reading the directory list maybe is not on top of your list, but the concept is that you pass just one row as an input and then you explode this list as long as there is a match in your function call. Hope it makes sense. Let's go into another very common topic that is, no, this one, okay, that is hierarchies. How to browse through hierarchies. In your employee table, you have the relationship between the employee and the manager. So you want to see the line hierarchy for each employee. How to do it? Different solutions for it as well. Plenty of solutions in the documentation, in the online forums, blah, blah, blah. Of course, you can also do it using a cross apply. So let's see how to do it. Yeah, you can call a recursive function that calls itself using a cross apply. Let's have a look, couple of samples on it as well. Okay, so Adventure works. So I have my dim employee table with the relationship between the employee ID and the manager ID. Very, very common way to do it. It's a recursive CT. I'm declaring one employee login name. Then somewhere, okay, so this is the starting point, the anchor member for the CT, recursive CT, the starting point. And then you have the recursive CT that calls itself as many times as we have into the list. So this is a common way to browse through hierarchies, and it works. Okay, so you have this is our starting point, so our employee, Sandra, and then this is the hierarchy up to the CEO. The CEO he has nobody over, so there is a null for this is the reason why we have a null, because it's the top level of our hierarchy. Oh, okay, it works. It's fine and nothing to say. It works. But recursion and CTs can run into performance issues, and you have some limitations. And by the way, I don't know if you try to pass directly the list of the full list of employees, calling a recursive CT, you probably run into some performance issues, or you hit the cap, because there is a cap of 100 iterations, just for avoiding that then you kill your engine. So we can do it calling a function, and we can do it actually creating a recursive function. So I have a function get hemp hierarchy in the form of table valued function. No, this is a multi-statement value function that gives me back as an output a table variable. So the output is a table variable, and yes, because then we start each statement inserting into the table variable the output of the statement. So I pass the employee ID to the function, just the employee ID, and this is the first call. Read from the dim employee, where the employee ID is the parameter. But this is the trick, because the next calls, they are calling the function recursively. So you are calling the function recursively. It's pretty much the same concept that you have into the CTE. It's not, it was not easy to create it. So many attempts. You are getting it for free, so you are lucky. But there was a cost behind it. It was many hours of testing and brain draining. Okay, so the concept behind is that you call as a recursively the function, as long as there is a correspondence. So the function actually works because now this is just one single call. So I have the employee with the ID 125. And if I call the employee, it gives me the hierarchy for the employee. So again, I have employee ID and then line manager, and then I'm browsing through the line hierarchy up to the CO. But you can do it calling directly the full table with a cross apply that passes the employee key from the column. So right now I'm calling the employee table, dim employee table, and I'm passing through the function the employee key. And this is what happens. And note that it was pretty fast. Of course, it's because I already have in my cache. So of course it's cached, but it's really fast, believe me. So, and this is what you have. You have for each employee, E. Gilbert, you have the full hierarchy. Starting from the employee level, I also added the row number. So you're starting from employee level, and then you are browsing through the hierarchy up to the highest level, the CO. And there are different levels of hierarchy. In this case, we have 5 levels. I see. Okay. So in one call, you have the full hierarchy of all your employees. This is the employee table from AdventureWorks. I have to be honest, I didn't test it on larger tables. We are keeping it, we are using in tables that have no more than 1,000 employees. I have no, I didn't test on larger tables. Might be that you run into performance issue, but the point is that you have one very simple and polite script, and you can call one employee if you pass just a single login here, or you can pass a table, a view or subset of data, and then you have the full hierarchy expanded. Okay. Yes, I think we are, yeah, closing. Yes, I have some other examples. Maybe this one we can take a quick look on it. It's the top number of customers, orders, or whatever. This is another common example where the apply operator it's really helpful. So yes, you have this. And I made it by purpose. I could have created a function, but you can also call directly the SQL script into your outer apply. It's up to you. You can either create a function, or so if it's something that you use quite often, or you can just wrap your script into the outer apply. It's the same concept, just to show you a different option. So in this case, I'm not calling a function, I'm calling a query inside directly inside the outer apply, and the query is giving me the top 3 orders, I think, based on the department. This is the output.
I find that this is how I use apply most of the time. I just write the select statement and it runs once for each row. It's easier to maintain, I guess. Yeah,
I understand. I agree. I'm doing it quite often as well, but I wanted to stress the concept of the functions, because once you understand it, then you can master the operator. Okay, so for this sales rep, Amy Alberts, we have the last 3 orders, for instance. So this is a common case where you can get out some selected rows without doing any complicated stuff in your SQL. Okay, that was it from my end. Don't know if we have any question.
I don't see any questions. I think it was a great presentation. It's a great introduction to apply. And like I mentioned in our before talk, apply is like the sort of the next level of what you can do with t-SQL. If you can get that kind of procedural logic. I tend to think of apply as for each, for all of you who write PowerShell. It's basically for each row, do this, and then you can just ad lib a SQL statement, and that is so powerful, definitely. So I think this is a super valuable session.
Thank you very much. Yes. Again, it's nothing new, but from time to time it's worth refreshing some.
It's not new, but it's the stuff we need. This is what we need to learn.
Yes, indeed. And it's always good sharing experiences, or also how to say, all the hours behind
yes
your achievement. But if you can save someone else's hours, then it's great.
Yes. Also, Thomas and Jay say thank you.
Thank you for for listening.
Cool. And with that, you're a pro, sir. With 40 seconds to go until our just perfect.
Thank you very much.
That's all we have for today. And on behalf of Magnus and all the, so thank you everyone for showing up, and see you next week.
See you.